Alright, 6-12, dividing polynomials. Recall back when we did the exponents chapter. If you had x to the fifth over x squared, I told you to expand all of your exponents. I've got x to the fifth, that's 5x's multiplied together. X squared is 2 multiplied together. And when you have the same letter on top and bottom of a fraction bar, they cancel each other out, and however many left is your answer. So the reason that worked is because when we factored out the original problem, that was expanding the original exponent. When you have the same letter on top and bottom, you can cancel them out. But you have to be careful because this only works with factors, which is talking about multiplication, not addition. So here's some examples underneath what I'm talking about. If we have 8 divided by 2, we know that thing equals 4. So if I was going to expand 8 as breaking it down into the factors of 8, 2 times 2 is 4, times 2 gives me 8, so this is still the same problem. And if I cancel out what they have in common on top and bottom, then I've got 2 times 2, which is 4. So these two things are the exact same thing. This is okay. But if I tried to break up 8 using addition, 2 plus 2 plus 2 plus 2, and then I cancel out one thing that they have in common, now this thing is telling me that my answer is 2 plus 2 plus 2, which is 6. So that thing does not work. That's why this works with multiplication, but not with addition. Okay? So what we're going to do on these problems is factor anything possible. Then we need to cancel out common factors on both sides of the fraction bar. So when I'm looking at example number 1, on the top I've got a trinomial. So I'm going to come over to the side and rewrite that problem because I'm going to factor it. Now it is one of those problems that does not have a number in the very front, so that means I can go ahead and put my a in each one of those first set of parentheses. I'm going to list the factors of a negative 30. So that could be negative 1 times 30, negative 2 times 15, could be negative 3 times 10, or negative 5 times 6. Now these two add to give me a positive 1, and since I need a negative 1, let's flip it around so that I need 5 and negative 6. So I'm going to put plus 5 and minus 6. Now when you look at the bottom, that one does not need to have to be factored because there's only 2 terms and there's a subtraction sign, but this is not a difference of squares because a is not a perfect square and 6 is not a perfect square, so I cannot factor it. So now I'm going to rewrite my problem with my new factors on the top. I've got a plus 5 times a minus 6 on the top, and on the bottom I only had that a minus 6. Now whenever you can't factor anything on the bottom, I like to go ahead and put it in parentheses, so it's a little bit easier for you to see exactly what we have on the top and the bottom. I've factored these two things out. There's things being multiplied, so that's why I can use this method. A minus 6 and a minus 6 cancel each other out. So that means my answer is whatever's remaining, and that's a plus 5. Remember, when there's nothing on the bottom of your fraction, you do not have to put the 1, so I would just write my answer like this. All right, example number 2. Same idea, but this time I've got 2 trinomials, so it looks like I'm going to have to factor both. So let's come over to the side. I'm going to do the first one in blue. That's x squared plus 6x plus 5. If I'm going to factor that thing, it starts with a regular x, so I'm going to go ahead and put my x's in the parentheses. And my factors of 5 are just 1 times 5. Those two do add up to give me 6. So I'm going to put plus 1 and plus 5 in my parentheses. So there's that first one. Now let's look at the second one. I'm dealing with x squared plus 5x plus 4. And I need to factor that one. Now it also starts off with a regular x squared, so I'm going to go ahead and put my x's in my parentheses. The factors of 4 could be 1 times 4 or 2 times 2, but the pair that adds to give me 5 is 1 and 4. So I'm going to put plus 1 and plus 4. So now that I've factored both sides of this division bar, I'm going to rewrite my problem. The top one, I'm going to go ahead and put that in blue so that you can see it. That one was x plus 1 times x plus 5. The bottom one, when I factored that one out, was x plus 1 times x plus 4. Now that I have both sides factor out, I can cancel out anything that they have in common on top and bottom. So I've got x plus 1 and x plus 1. Those two things cancel each other out. And what I have remaining is my answer. So I'm going to go ahead and write down here, my answer is x plus 5 divided by x plus 4. Now some of you might be thinking, okay, we've got the same letter on top and bottom of the fraction bar, why can't we cancel those out? Well, remember what I just said. That only works for multiplication, not for addition. And right now, we've got a couple of addition problems. So that's why we cannot cancel out those x's. Let's look at example number 3. Now, when you're looking at this problem, you've got to determine how you are going to factor this. Now, on the top, I have a subtraction sign between two terms. X squared is a perfect square, 16 is a perfect square, so that's what I need to factor. So I'm going to take those two apart, and if I take the square root of x squared, that one just gives me a regular x. When I take the square root of 16, that one gives me 4. So the pattern for a difference of squares is to add your two terms, so x plus 4, and to subtract them from each other, x minus 4. Now, when I look at the bottom part of that fraction, I don't have to factor anything because it's only two terms and there's no subtraction sign, so it's definitely not a difference of squares. So let's rewrite this problem. X plus 4 times x minus 4 for the top part, the x squared minus 16, and that whole thing is still being divided by x plus 4. So now what I'm going to do is cancel out what they have in common on top and bottom. X plus 4, those two things are gone. And so now my answer is x minus 4, whatever's remaining. So number 4 is the same type of problem. I'm going to go ahead and factor out the difference of squares on the top. So I've got x squared minus 121. I know that is a perfect difference of squares because the square root of x squared is x, and the square root of 121 is 11. So now all I need to do is put it back into my difference of squares format. I'm going to take x plus 11 times x minus 11. So there's that top part of the fraction bar. Now when I look at the bottom, that one has 1, 2, 3 terms. It's a trinomial, so we need to try to factor that one as well. So I'm going to rewrite it down here so that you know which problem we're working with. And I'm going to go ahead and start each one of my parentheses with x. So I'm going to take the factors of 11, which could only be 1 times 11, but those two do add up to give me 12, so it's what I need. Plus 1 and plus 11. So now let's rewrite this fraction bar with our two new terms. So the top part, that was the x squared minus 121. Now it's going to be x plus 11 times x minus 11. Okay. For the bottom row, that one was x squared plus 12x plus 11. So now that one is x plus 1 times x plus 11. So now what I need to do is cancel out what we have in common on top and bottom of the fraction bar. So what I see in common, I've got an x plus 11 here and an x plus 11 here. Don't have anything else in common, so now I'm going to bring down my answer. X minus 11 is still on the top of the fraction bar, and x plus 1 goes on the bottom. So I've got x minus 11 over x plus 1. Now all of the problems that I'm going to give you on the homework are these kind of factoring problems where you just have to start with the letter x. But just in case they ever show something different on the star, I did go ahead and put one example of how you're supposed to factor whenever there is that number in front of your x squared. So let's come over to the side. I've got 2x squared minus 5x minus 3. Remember, this is the method where you're going to say, okay, I'm going to take the first number times the last number, and that gives me negative 6. So it could be negative 1 times 6, 1 times a negative 6, and it could also be 2 and 3, but I'm going to stop right there because 1 minus 6 gives me a negative 5, or 1 plus a negative 6. So now I'm going to rewrite that problem as 2x squared plus 1x's minus 6x's minus 3. I've turned that problem into a factor by grouping problem, so now let's break it apart. Greatest common factor between 2 and 1 is just 1, and between x squared and x, I can take out an x. Okay. So I'm going to divide an x out of each one of those terms, which is going to leave me with 2x plus 1 inside my parentheses. Okay. Now the greatest common factor between -6 and 3 is 3, and because the first thing I see is a negative sign right there, I'm taking out a -3. So divide both of those terms by a -3, which turns this into a positive 2x and this into a positive 1. Now I do have the exact same thing in both parentheses. I've got 2x plus 1, and then I also have x minus 3 inside the parentheses. The leftovers go in the other one. So there is my first term on the top. I've got that thing factored. Now we also have to worry about the bottom. So if I've got x squared minus 6x plus 9, I need to be able to factor it. When there's not a number in front of your x squared, that's when you can go ahead and put your x's in your parentheses. List the factors of 9. Could be 1 and 9, it could be 3 and 3, but neither one of those add up to give me -6. But don't forget that whenever you have a positive factor, you could also multiply two negative numbers to get that positive number. So these two do add up to give me -6, so I need -3 and -3. Okay, so I factored both of those problems. Now let's rewrite this problem using our new factors. We said the bottom row, or the top row, is actually 2x plus 1 times x minus 3. We did all that factoring right there. So that's 2x plus 1 times x minus 3. And we said that the bottom row, the denominator, factored into x minus 3 times x minus 3. So now I just need to cancel out what they have in common on top and bottom. That gets rid of an x minus 3 and an x minus 3. And what I have remaining is 2x plus 1 on the top and x minus 3 on the bottom. And once again, I cannot cancel out the x's because these are a couple of addition and subtraction problems. They're not multiplication, so you can't cancel anything out.